Cool. And so this session is going to be the first of our Code in Prod sessions. And I've already kind of introduced myself, but I'll kind of let Ed introduce himself from AT&T.
So my name's Ed Barmettler. I am a new product development engineer at AT&T. I've been there for about 15 years now, working primarily in the lab operations team. In the last 2 years, mostly focused on trying to automate operations work using the ontology and more recently Gen AI with AIP.
Cool. Just to kind of run you down what we're going to cover in this session, we've already done introductions. Ed's going to give a bit of an introduction about AT&T, though most of you are probably familiar with AT&T, and then we're going to talk about AT&T's relationship with Palantir. We'll dive into a description of the problem statement that we're going to be solving here using a lot of the tools you've seen in the product launch session. Ed's going to walk through a live demonstration, talk a little bit about how users like this in production, and then I'll talk a little bit about stuff that you might be able to take from this session to use in your own build sessions. So Ed, if you'd like to give, we already done introductions, if you'd like to give an introduction about AT&T.
So most of you probably know AT&T, but in case you don't, it is a very large telecommunications company here in America. We were originally founded in 1885, and even back then, the culture of AT&T and the goal of AT&T was to connect people together. So we used to be the telephone and telegraph company. Now we're just AT&T. And that's still true today. Our primary product offerings right now are essentially 5G and fiber broadband. We really believe that connecting changes everything. That's our brand. And that is essentially what we do. So AT&T and Palantir have actually had a fairly long relationship. We've been working together since 2019. I've only been working on it since like 2 years ago. But we worked really early with Palantir to see if we could take the network that AT&T has and try bring it into the ontology and build a digital twin of AT&T's network. And I think we've actually had several workflows that are kind of listed on here that have actually been very successful from that digital twin effort. Call Before You Dig is probably the only one you'll recognize. But actually, Dan and Mark gave a presentation at AIPCon last year that was really good, that kind of covered a little bit more of a broader, here's what AT&T is doing with Foundry right now. It's worth looking at if you're curious about kind of the larger effort. Just a couple quick metrics on here. I'm going to run through these slides really fast because I got way too much to cover. We have about 650 use cases. 36,000 people have been logged into the platform at one point or another. It's about 8,500 that are logging in every month. And we've got about 1,000 data sources that have multiple data sets coming in, both tabular and media. And this is early on still. I think AT&T is still kind of leaning into, I almost called it deep, leaning into Foundry. That's what we call internally. And these numbers are just going to get bigger and bigger as we get more and more value out of the ontology. So like I said, I work in operations. So my goal is to try and make operations more efficient. The big issue that I've been chasing for the last 2 years is tickets are too expensive. They take too long to solve. We get too many of them. Users don't always triage them as much as they should. So when generative AI started to get onto the scene and we started to look at triage chatbots and RAG and the ability to maybe use the ontology to feed that, this was an immediate use case for us. This was like one of the first use cases we chased out was, let's take all of our data, let's give our internal users and our support teams the ability to search through our data and hopefully self-triage, or if it has to be solved by the support team can reduce the MTTI, the time it takes to figure out what the issue is. This works really well for structured data, bringing in monitoring data, inventory data, change management data. They're all tabular. You throw in the ontology. Everything just kind of works out of the box. You can build these chat bots that do RAG right away. There's no issues. The thing we've really struggled with, and the solution we've been chasing that we're going to demo today, is the unstructured data. It's the institutional knowledge that is what we do, how we do it. It's our acronyms, it's our business processes. It's things that if you just ask GPT-4 right now, it's going to hallucinate like crazy on. And that has been our biggest challenge. Either they're very like handcrafted knowledge base articles and wikis that people take a long time to build, or more likely, and what we're going to be using today, just chaos in ticketing systems where the engineers will document what they did, document how they fixed it, and then they'll never look at that ticket again because ticket searches are usually not that great.
So Ed, would it be fair to say that the goal here is kind of twofold, right? Responding to support tickets with high quality responses without a human involved, And then second goal, taking that large corpus of support tickets and turning them into high-quality knowledge base articles that can be used to answer future ones.
Exactly. So ticket volume reduction and just a rich, distilled set of knowledge base articles from a much, much larger set of chaotic tickets.
Nice. Let's see it in production.
All right, so let's flip over to the demo. All right, I am in the demo now. So I always like to kind of start these demos at the end. This is essentially what we built. I'm just going to show you guys real quick. This is just a chatbot in Foundry. And I'm going to ask it a really quick question that it shouldn't be able to answer without our institutional knowledge. And it is worth noting this is notional data. I can't show you real tickets. So you'll see big numbers, and those are real. But anything that's the actual ticket text is going to be something I invented for DevCon. So in this case, the user is going to say, I'm having an issue deleting a device from tracks, which is a fake tool I invented. It says it doesn't exist. And this is actually based on a real issue I've seen in corporate America. Multiple different ticketing or tooling systems have connections to each other. If they get out of sync, if devices are in one system but not another, the whole thing kind of breaks. This is actually based on a real ticket. It's going to take a second, and then it's going to come back with an answer from the knowledge base. And there it is. So you see right here, it's going to give the user a really quick answer up here at the top. Hey, your issue is because Tracks is not synchronized with IGR for that one asset. Here's some steps that the user can run just to verify that that actually is the issue. And then here's the things that my team can actually go in and immediately do to solve it. And this is all based off of an actual knowledge base article that was generated completely by AI.
And the thing I really like, if you scroll to the bottom there, is to the gentleman's question earlier, we have referencing. So you can see that hyperlink. You can reference the knowledge base article here on that link there. That will link us back to the where the LLM has received its information from. So we can know that even if sort of the details are incorrect, you can reference them back against something that's been verified by a human rather than that just individual response.
Yeah, and this is actually the example of the knowledge base article that it had. It has the very basic. I structured these knowledge base articles to be easy for an LLM to consume and for humans to read. We have symptoms, we have details, we have the resolution steps with the individual commands. And then what's really important here, and the reason I went over here, is it's actually using data from more than one ticket to build these knowledge base articles. We don't want to just generate. I have 50,000 tickets in this solution that we've built. We started with a sample of 50,000 tickets over, I'll just show you, over about 4-ish years, so pre-2021 through now. And I don't want 50,000 knowledge base articles. I want to get the distilled knowledge from all of those, especially if one ticket has half the solution and another ticket has the other half the solution, because humans we're random. We want to have that distillation down. So how did we actually build this? I'm going to show you this in Solution Designer. This is a super simplified version of the actual design, which is off to the right. I just kind of simplified it for ease of demoing here. I'm going to show you what the ticket actually looks like when we bring it in. And this actually brings in the imaging problem. Humans are, I don't want to say lazy, they're busy. They will take a screen capture instead of giving me an error message every time. So this user's come in, they've complained about this issue, they have a screen cap from a website or from a workshop app, and then there's a bunch of commentary back and forth. The engineers are sometimes copying and pasting the commands they're running, sometimes they're taking screenshots. So the first issue I have is a data prep issue. I've got to get half the conversation out of images and into text. That way the LM can actually work with them. And we are going to use Pipeline Builder for this, which have we covered that yet?
I don't think we've covered that yet. So yeah, Pipeline Builder is essentially a low, no code way of writing data processing pipelines, including accessing LLM. So what Ed's going to show here is how we're using multimodal models to extract not just, say, OCR information, but also contextual information. I really like Ed's example here.
So just as a reference, it's 50,000 tickets in our real data set. It's about 30,000 images. That's a lot of images. You're only going to see a few in the demo here. This one is the one I like to pull up to explain why we didn't just use traditional OCR. This is an example of the error message is not actually here in text. It's kind of implied with the red box and the dashes around it. A human knows disk 4 is the reason why this disk array has failed. And a simple text scrape is not going to get you that. So GPT-4o is multimodal. We have the ability for it to take this media set of thousands of images or attachments. And I'm going to go ahead and open this up real quick. I'm actually going to cheat here and go get the media reference directly from a notepad because I don't want to have to go find it. And then I'm going to run this real quick just so you guys can see what it looks like as I'm explaining it. That's going to take just a couple seconds. So we want two things from these images. We want the description, the contextual description of what's in the image. Is it a Wireshark trace? Is it a terminal command? Is it like a Dell iDRAC? And then what is the actual error message text in it? So we've got a quick prompt in here. It's right in the LLM, or it's right in the pipeline. It's just an LLM node. We're giving it our image, which is the media reference. And then we're asking it to give us a struct back of all of the different things we're asking for in one node. I don't chain these nodes together. I try and do as much as I can in one node, as long as I don't lose context, because it's a lot faster and less tokens to ask all of the same type of questions together. And then the other thing here worth calling out is I never want to process these images again. 30,000 was enough. It was a long weekend. If you turn skip computing rows on, it'll only ever look at new images as they show up in the media set. And you can see in this example, it knows disk 4 failed. It's saying disk 4 failed because it's going to have like red detailing around it, while the other ones are green. So this is giving us confidence that we can have the whole conversation now of these tickets. It's not just going to be the half that's just the text. We take all of the images, we convert them to text, we merge them back into the ticketing, and I've got the entire conversation now. So that's step one. Step one is just data prep. Step two is kind of continuing my problem. I've got 50,000 tickets here. I don't want 50,000 knowledge base articles. Not all these tickets are good support tickets. They don't have good content. Sometimes they're not really actually support tickets. Sometimes the engineers went in and said, hey, I fixed it, and that's all they said. So if we're really going to try and drive like distilled knowledge into a common set of knowledge base articles, I only want the really good content. So what I need to do is I need to score all these tickets when they're closed, look at all the details, the comments, and decide, is this a ticket that's worth bringing into my knowledge base? And we're going to use Automate, and we're going to use AIP logic to do kind of everything here going forward.
And whilst Ed's pulling that up, one thing I want to highlight here is the quality of the problem decomposition that Ed has achieved here. And I think that's really key, as I'm sure a lot of you guys are aware, for LLM-based workflows, breaking it down into tasks that are tractable for an LLM to do, rather than trying to throw all of the tickets at an LLM being like, write me some knowledge base articles. Instead, it's like, okay, well, how can we break that down into a series of steps? And the first one, this is what Edward's talking about, rating those tickets, like which ones are the quality ones?
Exactly. So this is what the Automate looks like. This is a production Automate. We're grabbing all the tickets that have one of the many versions of closed in our ticketing system, and if they don't have a score yet. And you can kind of see here, this has been running for a while. It's only going to show you the last 2 weeks, but every time a ticket's closed, it's just automatically scoring those tickets, and it's adding them back into the ontology with that score. It's calling this logic function, evaluate and score tickets, which is this guy right here. I'm going to kick this off as another example, just so we don't have to wait for it, using a fake ticket. And then I'm bringing in my support ticket as an object. So the ontology, or the Automate's going to take the object that was added, that was closed, feeds it right into an AIP logic function. And we've got a couple steps in here. I'm going to cover a little bit more in a minute, but essentially half the LLM prompt is actually dynamic. How we score, the rules of scoring, we've made that something that's actually defined and managed in our ontology. We don't want to hard code it. I don't want to manage it. I want my operators to kind of let it evolve over time with their feedback. So you actually see half of the prompt here is missing, but it's in there. It'll run. And then we're giving it all the details from our tickets, the summary, the comments, the images, and we're providing all of that. And then we're coming back with two things. We need a score from 1 to 10, 10 being perfect, which we don't get, and 1 being don't use it. And then we're also asking it for reasoning. The reason we kind of do this is twofold. Anecdotally, sometimes we get better answers when we ask the bot to show its work. I think it's just how it was trained. But more importantly, if we capture the reasoning for why it was scored, we store that with the ticket in the ontology, it's a lot easier to go back and understand why these were scored the way they were. And sometimes it's over-rotating on the prompt. Sometimes it's we thought it scored wrong, but when we read the reasoning, we actually kind of agreed with it. So everywhere you're going to see me use these LLM prompts, you're going to see me try and capture the moment of reasoning from the bot, and it just makes troubleshooting so much easier. And then the actual response here, you're going to see, I'm not going to show too many of these examples because they all start to look the same. It gave us a score of 9, and it gave us a reasoning where it's got really good resolution steps. It has a very clear problem statement. There's a good back and forth. Overall, it's a 9 out of 10. And if I showed you a different example that was like a 4 out of 10, it'd be like, they didn't say how they fixed it. They just kind of, it's fixed. So Now what we do is we take this and we use, going forward, Automate's going to do this automatically for every new ticket that gets closed. But Automate also lets us go backwards and bulk run this against all of our tickets, which is what we did. And we basically came up with a score distribution that looks like this. No 10s, but a lot of 8s, a lot of 3s and 2s. And then we went and looked at where we thought our boundary should be. And it was kind of a question of, is it a 7 or a 6? Where do I draw my floor? Where do I draw my line? And after looking at a lot of the data in the first couple runs of this, we kind of decided 7 is good, 7 is always good, 6 is sometimes bad. So we kind of drew the line and said, anything that's a 7 or higher in the score, we're going to go process those. Anything that's a 6, if I'm desperate, I can go get those. And that ends up being about 1/3 of our data. It's about 17,000 tickets of our 50,000 tickets have a score that is a 7 or higher. So I've solved one of my problems. Now I'm no longer trying to build 50,000 knowledge base articles from 50,000 tickets. I'm down to 17,000. But that's still too many because some of these tickets, most of these tickets, the same issue occurs more than once. So what I really don't want is I don't want 17,000 knowledge base articles. I want like 4,000 knowledge base articles. And I only want it to be if it's new and I've never seen it before, that's when I want to create a knowledge base article. If it's something I have seen before, just modify one of the existing ones. So the third step here is actually generating our knowledge base. This is using Automate again. I'm big on Automate. I was so happy you guys were like promoting it today. I was like, yeah. It is an unsung hero inside of my organization, and I think people sleep on it. They use it for notifications, and I'm like, no, this is so much more powerful than that. So Automate's basically going to react to any tickets that are closed that get a score of 7 or higher. It's going to pick them up. It's going to send them over to this logic function. And this logic function has one job. Its job is to take the issue that's actually in these tickets and then to go search the existing ontology of our knowledge bases and see if the same issue already exists. We actually do use code for this. This is the first place we're using code in this example. It's one of 2 places we have to use code. Everything else has been no code. And we're doing an advanced semantic search, which we borrowed from Palantir. Thank you for that. Yeah. And it's a combination of a vector cosine search of embeddings of these knowledge base articles, a hide search, which is like a fancier version of that, a keyword search, and an augmented keyword search. And then this function kind of takes all those results, combines them together, ranks them, and gives them back to our logic function. And the logic function then has, here are like the top 5 articles that might match this issue. Are any of these the same thing? And AIP gets to make a decision now. If there's a close enough overlap here where this is the same issue, but I've got some good data here, I'm going to send it off to a child logic function down here that's going to modify one of my existing articles. I send it the new ticket and the old article, and it kind of builds a new version of that article. But if it's something new we've never seen before, it's going to generate a brand new article within minutes of the ticket being closed.
And it's fair to say then that this is sort of a cohorting process, but a dynamic one.
Exactly.
Cohorting those articles together.
And I'm letting AIP do everything up to this point because I don't want to have humans slowing this part of the process down. So now we end up with thousands of tickets, tens of thousands of tickets in the sample set, turning into just a couple thousand knowledge base articles. And they really are kind of distilling down into just the issue itself, not the tickets necessarily. So the fourth step of 5, I'm going to check my time here. I'm doing good. The fourth step of 5 is kind of 2 different things. One is safety, and one is integration with our existing tooling. I have to talk about safety. AT&T is very aggressive on Gen AI safety. I think we're very forward on that. You'll hear us talk about it a bunch publicly. These LLMs will hallucinate like crazy if you let them. And they will make really weird decisions if you poorly tune them. So we try, whenever we bring a new large language model use case, a new generative AI use case into our systems, we try and come up with, at the very beginning, what is the guardrail for this? What's the human in the loop part of this? And in this case, it was really easy. I'm going to let the machine do as much as it can to generate new drafts of new or existing articles. I'm going to have a human come in and do publishing. They're going to vet it. They're going to spot check it. Really looking for anything dangerous, like don't drop a database. That's a bad idea. But maybe also clean it up a little bit and give us feedback on how well it's doing. So the humans are there to make sure that anything that could be used by our downstream customers, internal, but they're still customers, or anything that would be used in automation has kind of been vetted by a human and it's got that published flag on it. The second half of this is, you saw this working in Foundry. Foundry is awesome. It just works right out of the box. It took me seconds to make that chatbot. Half my tools don't exist in Foundry. I've got legacy support tooling. I've got a global AT&T chatbot that I don't own that we use. I'm not going to get those into Foundry, but I want this data to be available to them. I don't want to have to recreate the solution somewhere else or try and do some weird like data shifting somewhere. So OSDK has been a huge help for us on being able to provide this data and the larger ecosystem of our ontology to these not third-party applications, but like other organizations in the company, and letting them have the power of the ontology. And it's starting to set up sort of a concept for us of ontology as a backend, where we do everything we can there. All of my AIP stuff, all my LLM stuff is in AIP. All of my data modeling is done there. And then your front end can be whatever you want it to be. If you got a custom chatbot, have fun. Use OSDK, plug it in. If you want to build it in Foundry, it's going to be a little faster. I don't know if you want to add anything about OSDK.
No, I would say OSDK, I'm sure lots of people here have already used it, but really powerful tool for kind of, I guess we'd call it escape hatches, right, outside of Foundry for when Foundry's not doing what you want to do because it's either too niche or too complicated or we haven't got there yet. And so you're able to use that in your build sessions. Think about how you might be able to use that to kind of integrate with systems or produce custom UIs.
So going back to kind of the operator side of this, we want our operators, these are the people who are like the support engineers, 30 or 40 people who are actually like vetting these articles and publishing them, and they're the ones who would be giving us feedback on them. We want them to be able to easily go in, publish articles, flag articles, fix them with new versions, and we also want them to be able to go and at any point in that solution diagram you saw, be able to manually do those steps themselves. So you're going to see like down here at the bottom, the top is all about consuming the data and using the data. The bottom is more of the operator piece here where I can have the operators come in and rescore tickets that were scored wrong, or maybe we fixed the prompt and we need to rerun the scoring. We can generate knowledge base articles manually if we need to. There's none available in the sample data. We can also just generate knowledge base articles by scratch. If you've already got a wiki or a bunch of wikis, just copy them, paste them into this, as long as there's no images. And you're off and running. So we're giving them as many tools as we can internally to manage the overall ecosystem without having to call a developer or troubleshoot code or anything like that. The other thing I will talk about real quick is sort of the challenge we have next. So I've got all these articles. I've started to generate them. They're okay. They're not great. I get the users to start giving me feedback on them, and very quickly it becomes get 40 people onto a call and start modifying prompts by committee, which is a terrible experience. Don't do that. So we need feedback. And why not just get feedback from the users directly? They can manage their articles here. They can create new drafts. They can publish them. But they can also provide feedback. So we give them the ability right in the article, right in workshop to say, hey, there's an issue with this article. It's poorly written. The example you'll see here in a second is when we first built these, they would include users' information in like the description of what happened. Like, hey, we've seen this issue before. For example, this person's name had this problem. And it was like, we were shaming users. We shouldn't do that. So quick feedback, hey, LLMs don't do that in the future. So they might type that out explicitly, but like you were saying earlier, feedback is really hard to get from our users. They don't want to take the extra time to click the thumb up button. So is there a way that we can get this feedback more directly just by capturing what the humans are doing in the tool? So if a human comes in here and they see this issue where a user is being referenced, they can come in here, they can create a new version, they can go in and edit what needs to be fixed. Maybe they're doing white space cleanup. Maybe they're removing details that shouldn't be in there because they're sensitive, like a person. And then they can save that new version of that article. And then we can actually use automate and AIP again, AIP logic, and I've actually got a diagram of this, to capture this data implicitly. So what it does is it notices that there was a machine version of the article. A human edited it, so there's a new version that a human touched. I don't care if the machine keeps improving on its own. I need to go in and look at that. And we use an AIP logic function to generate that implicit feedback by looking at the original, looking at the new, and not just figuring out what the diff is, but trying to guess at what the human intention was. And then we store that same exact feedback in the exact place that we store the explicit feedback. It's just in the ontology. And then I have a button I can click at any point to take all of that feedback or a subset of it and generate those new versions of those existing prompts.
I think you have some examples of that user
Yeah.
feedback, right? And Ed is being overly modest here. This is one of the coolest things that I have seen in a very long time. When Ed first gave me the demo, I was just like jaw dropped. And just to like kind of pitch you what's going on in my sort of the way I think about it, these pieces of feedbacks, like they are feedback on a prompt, right? They were not written by a human. They are just inferred from the email. So for example, someone stripped out the user's names. Pass that into an LLM, it turns it into do not include users' names. You now have an entire corpus of these pieces of feedback. So let's go to a future article should avoid using usernames. That's a great example. Each one of these items has been generated without a user having to do anything other than edit the knowledge base article. And then you can take all of those and use those to regenerate a prompt. This is essentially like asking an LLM, hey, if you were going to write a prompt for an LLM, how would you do it given this feedback? And so now Ed doesn't have to, I mean, no one wants to write prompts, right? You want to write code, I don't want to write prompts. And so you're taking this and using it to dynamically generate a prompt. And I think this is something that's happening in sort of the literature, but which I've very rarely seen in production use cases, and which is why I was very impressed and shocked when Ed showed me that demonstration.
Pure necessity. I did not want to be managing these prompts. So you can see in this example, and I'll be pretty quick here. I started with, this is the demo version of the prompt. I can't show you my real one. But I started with the most laziest prompt I could think of, which was the article should be well written. And it did okay. It was rough. And then we had our users kind of go back in and give feedback. And that was where they were saying, hey, you got to actually put the commands in here. There's explicit feedback like you didn't actually include any of the details. Just go run the command, but not what command. They gave that explicit feedback. But they mostly actually just started editing articles really quickly. It was just like, I don't need to give it feedback. I'll just fix it. And we started to generate new versions of the prompt where you start to see it went from one line item in the guidelines to 3 more line items. And then if we keep going and we keep getting more and more feedback as we iterate through this, and this was over the course of like a week, we just generate a couple hundred articles, start vetting them, generate new prompts, generate more articles, vet them. But what happens very quickly is at some point, it starts to get to where there's enough in there already. And this is hard to see because it's zoomed in. I'll just zoom it out just a little bit so you can see the prompts stop getting longer as much, and they start to get just a little bit thicker. So the LLM's actually, AIP is actually smart enough to go, there's already a line item for this. The line item's already talking about like sensitive data. Instead of just adding a whole nother line item like a human might, because I'm not gonna read all that, it goes in and it says, hey, I should also exclude generic terms like locations as well. So, you know, the prompt is, the AIP is reading the entire prompt and it's adjusting as needed. And we're starting to see it kind of settle in as we give it more and more feedback. And I think that's it for the demo if we want to.
Yeah, I think you were going to go through some of the, if we switch back to the slides, we can just do really briefly on what the users think of this, because that was my first question. It was sort of, well, do people like it? What's going on? And perhaps you could answer that question, Ed.
The first piece of feedback I got was it's a little disturbing that this chatbot, and we've been using them for a couple of years, they're generic, they know the internet. When this chatbot starts talking to you with your acronyms, your business process, your understanding of things, it's like, whoa, this is almost, it's not human, but it trips you up for a second. I think the other things, the feedback we've gotten from the support team is, in the past, documenting the solutions in a ticket was always kind of like busy work a little bit. It was always like, well, we fixed it. We're never gonna look at this ticket again. There's no value in this data. Let's move on. Now they're starting to realize, wait, I should probably document the ticket I'm closing right now because it's going to show up in a knowledge base article in 10 minutes. So it's like, I'm gonna remember this 6 months from now and regret it if I don't, which is great because data quality is the biggest problem here. And then I think the biggest other piece is we've always struggled on what should a knowledge base be? Is this a corner case? Is this too broad, too vague? These are almost free to generate. They're basically free because the machine's doing the work. So now we don't have to worry about it. If we think we have a corner case, this didn't really happen that often, just generate the article, and if it's used, it's used. And if it's not, that's fine too.
I think we've kind of covered a lot of this other stuff. I was going to go through how you can be kind of using this in the build sessions, but my main theme here is that of automation and of making your ontology dynamically responding to various different things that are happening both within Foundry and also outside of Foundry. And trying to think of ways of how can you capture exhaust to improve the quality. That's sort of been the theme of both of the accidental theme, which I'm quite pleased with actually, of the demonstration that we showed with Austin and the demonstration we showed with Ed. And I see that we've literally just hit time, and so we won't be able to answer any questions right now, but I have a feeling that Ed might be rather hot property later on answering people's questions, because I think this is an extremely cool workflow.
I'm here for 2 days.
Indeed. Thank you very much.
All right, thank you.